Find adjoint A given a squared matrix A of second order defined as 1, 2, 3, 4. Now how do you define adjoint A? Adjoint A is defined as transpose of the corresponding cofactor matrix. That is, we'll find C11, C12, C21, C22. The sign convention is plus, minus, minus, plus. Let us find one by one and then we'll substitute. What is C11? Delete the row and column through 1 and you get 4 with the same sign, plus. What is C12? C12, delete the row and column through 2 and you get 3 with the same sign. For C12 it is change sign, so it will be minus 3. And then what about C21? C21, delete the row and column through 3, you get negative 2 and change the sign. So it will be C21, it is 2 and change the sign, so it will be negative 2. And then C22, for C22, delete the row and column through 4 and opposite is 1 with the same sign. Shall I repeat it again? For C11 you delete the row and column through 1, opposite number is 4 with the same sign, so it is 4. C12, it is 2, delete the row and column through 2, the opposite number is 3 with the change sign, so negative 3. Then C21, delete the row and column through 3, the opposite number is 2 but with the change sign here, so negative 2. For C22, delete the row and column through 4, the opposite number is 1 with the same sign 1. Just fill these values in adjoint A and you get adjoint A is transpose of, replace these values, that is 4, negative 3, negative 2, 1, and now take the transpose of it. So the elements of the first row, 4, negative 3, write in the first column, that of second row you write in the second column, and that way 4, negative 2, negative 3, 1 is the required adjoint A. Find adjoint A where A is a matrix of third order defined as elements of the first row are 1, negative 1, 2, second row are 2, 3, 5, third row the elements are negative 2, 0, 1. We have to find adjoint A. How do you define adjoint A? Adjoint A is defined as transpose of the corresponding, each element is to be replaced by corresponding cofactor, that is C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay. And the signs to be imposed will be like this: plus, minus, plus, plus, minus, plus, minus, plus. Okay. Keeping this in view, let me find all these one by one. What will be C11? Delete the row and column through A11. And for C11 you impose positive sign outside. And then what is the minor left? It is 3, 5, 0, 1. So you get here positive sign is outside, 3 into 1, 3, and minus 0 into 5, 0. So you get C11 equal to 3. Now then let me find C12. I am first finding C11, C12, C13, that is the cofactors of the elements of first row. Now delete the row and column through negative 1, but for C12 we have to take the negative sign. Negative times the determinant obtained by deleting the rows and column through negative 1, you get 2, 5, just see, minus 2, 1. Later you may do orally, but at present I am doing it in detail. So it is negative times 2 into 1, that is 2 and minus minus plus 10, so you get minus 12, and then minus 12. And then you work out C13. So for C13 we will take the positive sign outside, delete the row and column through 2, and you left with 2, 3, just check 2, 3, minus 2, 0. Yes. And now you work out, you get 2 into 0, 0, and minus minus plus 6. So C13 is 6. Now let me find out the cofactors of the element in the second row. That is, you work out C21. The sign for C21 will be negative. Delete the row and column through C21, that is through 2, and you left with negative 1, 2 and 0, 1. If you work it out, negative outside, negative 1 into 1, you get negative 1 minus 0 and negative, negative, positive 1. So you get C21. Now work out C23. For C23, for C22 you first work out C22. The sign will be plus. Delete the row and column through 2, 2. So you get 1, 2 and minus 2, 1. 1, 2 minus 2, 1. And when you work it out, you get plus is already out. 1 minus minus plus minus 2 and 2. Minus 4 and minus minus plus 4. So you get 5. And then you work out the value of C23. The sign is negative. And if you delete the row and column through C23, you will find 1 minus 1 and minus 2, 0. Minus sign outside. When you work out, 1 into 0 is 0, and minus 2 minus 1, 2, 0 minus 2 minus 2, and minus being outside, you will get plus 2. And now, let me find out the cofactors of the elements in the third column. Say C31. The sign is positive. Delete the row and column through A31 element, that is through negative 2, and you left with minus 1, 2, 3, 5. Please check. Minus 1, 2, 3, 5. Just work it out. Plus sign is out. So you have minus 5 and minus 3 into 2, 6. So you get minus 11. And then you work out C32. For 32, negative is the sign, and delete the row and column through 3, 2. So you get 1, 2, 2, 5. 1, 2, 2, 5. Minus sign is outside. You get 5 minus 4. That is 1. And minus sign being outside. Minus 1. And finally, let me work out C33. For 33, the sign is plus. Delete the row and column through A33. You get 1 minus 1, 2, 3. 1 minus 1, 2, 3. And when you work it out, you get 1 into 3, 3, and minus minus plus 2. So you get 5. So we have worked out all these. Here in this particular question, I have shown everything in detail. But later in exam, it is up to you that if you can work out orally or whatever. So what is the value of finally adjoint A? Adjoint A is transpose of the corresponding cofactors. Replacing the value of C11, C12, C13 are 3, minus 12, 6. And that in the second row you have calculated 1, 5 and 2. In the third row cofactors are negative 11, negative 1, 5. We have to find out cofactor. Never forget to take this, transpose. In some books you find that instead of first replacing each element by the corresponding cofactor, they directly write the cofactors of the elements of the first row in the first column and so on. But somehow I advise that first you write the cofactors in the corresponding places and then take transpose. And never forget to take the transpose. So what is finally the adjoint A by taking transpose? Elements of the first row, that is 3, negative 12, 6. You write in the first column 3, negative 12, 6. And similarly that of the second row 1, 5, 2 in the second column, and the third row negative 11, negative 1, 5 in the third column. So that way 3, 1, negative 11, negative 12, 5, negative 1, 6, 2, 5 is finally the required value of adjoint A.